5.3, solving polynomial equations. So a lot like we have been doing, but just dealing with more the quadratic formula. If you don't know the quadratic formula, you should write this down as a reference because we will be using this in this section. Remember, when I have my A, B, and C, the A is always in front of my x squared, B is always in front of my x, and C is always the number that is all by itself. The first thing I want to do here is set equal to 0. So I'm going to have 2x cubed minus 5x squared minus 3x, and that is in standard form. So I'm going to factor out, they all have an x in common. So I'm going to take out an x. Be left with 2x squared minus 5x minus 3. Now again, you can do the guess and check method or the trick method. If I'm going to be doing the guess and check method, I have the x out in front. I'm going to leave my two factors of 2 out in front, and the factors of 3 could be 3 and 1. Maybe negative 3, negative 1. Now it's just guessing and checking. Let's see, if I put negative 3 here, and if I put a positive 1 here, when I multiply this out, I would get 2 right here and negative 3 here. So negative 2 plus negative 3, that's equal to negative 1. That doesn't work. What if I checked 1 over here and negative 3 over here? So I'd have 2 times negative 3, which would give me a negative 6, and 1 times x would just give me 1. That gives me a negative 5. And that's what I'm looking for. So I'm going to keep those numbers where they are. Again, you could do the trick method, which we have done in class. Now we set each of these equal to 0. So x is equal to 0, 2x plus 1 is equal to 0, and x minus 3 is equal to 0. So my zeros here are at x is equal to 0. This would become a negative 1/2, and this would become a positive 3. So a little review of what we have done in 5.2. So again, still factoring and solving. So I move them all over. I have x to the 5th, and I'm going to add this 2x cubed to this to the 4x cubed. So I would get a total of 6x cubed. I'm leaving a space because I have to subtract 5x to the 4th. When I look at these three terms, I can take out an x cubed. So that would be like dividing each one of these by an x cubed. So I'll be left with x squared minus 5x plus 6, because I'm taking out 3 x's from each term. So then when I factor this, two numbers that multiply to get 6 add to get negative 5 would be negative 2 and negative 3. So I set all of these equal to 0. And my zeros would be at 0, 2, and 3, because I'm solving for them. So remember, it would be like adding 2 to both sides here, adding 3. Now this is where it gets a little bit different. So again, first I still want to set this equal to 0. But when I look at this right here, there's no number that I can take out of all of these. Now, if your variable goes by even numbers, like 4, 2, and then nothing, 0, you can still factor this. So I'm still going to look for two numbers that multiply to get 9, add together to get negative 10. Those two numbers would be negative 9 and negative 1. However, in order to get this every other term, you have to have the top two x's would be squared. Now you can always check your work. You could FOIL this out to see if you get the original, and you would. But now I can continue to factor these. So two numbers that multiply to get negative 1, but add to get 0, I could rewrite this as x plus 1, x minus 1. I could rewrite the second one as x plus 3, x minus 3. Again, these two numbers multiply to get the term, but add together to get 0. These two numbers multiply to get negative 9, add to get 0. So then my zeros would be at positive negative 1 and positive negative 3. Now another way that you could have solved this after once you factored, if you had that x squared minus 1 If you set that equal to 0, or if you had x squared minus 9 and set that equal to 0, and you solve these as is. So I have x squared be equal to 1 here, and then you take the square root. So this would give me x is equal to positive negative 1, because remember, whenever you take the square root here, you have to represent both positive and negative answers. So if I'm going to solve this one for x, I would have x squared is equal to 9, because I have to add 9 to both sides, and take the square root of both sides, and I get x is equal to positive negative 3. So either way, you're still going to get the same answer as above. And the last one for the video, I'm going to subtract my 10x squared over, so I'm going to have x cubed minus 10x squared plus 13x. I can take out an x right there. Left with x squared minus 10x plus 13. Now, 13 is a prime number, so the only numbers that multiply to get 13 are 13 and 1. There's no combination to get negative 10. So for this section right here, I'm going to have to use the quadratic formula. However, if you want to, you can have x is equal to 0. That would represent this 0 of the function. And then my a here is going to be equal to 1, because the 1 is in front. My b is equal to negative 10, because it's subtracting 10. My c is equal to 13. So I'm going to plug it into my opposite b plus or minus the square root. Make sure to have this in parentheses, b squared minus 4ac all over 2a. You always want to first simplify inside of the radical, but then to a calculator. And you get, this becomes a plus plus, so just 10 plus or minus the square root of 48 over 2. Now this is where you want to simplify this radical. So a perfect square that is divisible by 48, I can break this into 16 times 3. So now that I have my 16 and 3, take the square root of both of those. So this top would become 10 plus or minus, square root of 16 is going to be 4. Square root of 3, I can't do that, so I'm going to keep it as square root over 2. Now the final simplifying here, I can either simplify by, look what I can take out of the top, both of them have a 2 in common. This will be left with 5 plus or minus the square root of 2 square root 3 over 2, or else you can write your 2 fractions out. Now since it's multiplying, I can simplify this. So my zeros would be at 0, and then also 5 plus or minus 2 square root 3, again because these 2's cancel out. There's 3 zeros here. And that would be all you need to write down. Please make sure you have all of those examples down and have a wonderful evening, day, night, whatever.